I want you to do something for me right now.
Mm.
Don't overthink it. Just stop what you're doing, take a second, and look around the room you're in.
Okay.
If you're in the car, look at the dashboard. If you're on the train, look at the carriage.
Okay, I'm looking around the studio. What exactly am I hunting for?
I want you to count the electric motors you can see, just the ones you can physically see.
Oh, interesting. Okay, a little pop quiz to start. Well, I can see the vent for the air conditioner up on the ceiling. So there's a fan motor in there. That's one.
That's one. Keep going.
My laptop is right here. So, the cooling fan inside, does that count if I can't see it, but I know it's there?
Let's say yes for now. We'll get to the truly invisible ones later. So
Okay,
that's two.
okay, two. Uh, my phone is on the table. When it vibrates, that's a tiny little motor, a haptic engine.
It absolutely counts. So you're at three.
Three. This is actually harder than it sounds. I guess the clock on the wall, is that a motor?
A tiny stepper motor, yeah. And that's the point. You've got the fan, the AC. If you were standing in a modern kitchen, you'd be hitting double digits without even trying.
Oh, for sure. The blender, the fridge compressor, the microwave turntable.
The dishwasher pump, the exhaust hood, it's endless if you're driving a modern car. Forget about it. The wipers, the windows, the seat adjusters, the mirrors, the fuel pump, you can probably count 10, 15 without even breaking a sweat.
Sure. We are completely surrounded by things that spin. It's the foundation of, well, everything.
But here's the twist. That was the easy part. Now I want you to try and count the ones you can't see, the ones outside this room.
Ah, okay, so now the list gets a lot longer.
Yeah.
And a lot bigger.
Right. I'm talking about the massive water pump deep in the basement of this building that's giving us water pressure. The traction motors underneath the floor of the subway car you might have taken to get here.
The one screaming along at, 60 miles an hour.
Exactly. Or the massive generators in the power plant 50 miles away that are literally pushing the electrons to this outlet right here.
Elevators, escalators, the conveyor belts at the airport handling luggage.
It is the invisible infrastructure of modern life. We call it the invisible engine.
And we take it completely for granted.
We do, until it breaks. But here's the thing, and this brings us to the subject of today's deep dive. We are looking at a company that is absolutely critical to this entire invisible infrastructure, but they are somehow even more invisible than the motors themselves.
That's a very good way to put it. They are one layer deeper.
They don't make the fan. They don't make the train. They don't even technically make the final motor itself.
No, they make something much more fundamental. They make the physics work.
They make the guts. We are talking about Pitti Engineering Limited, ticker symbol PITTIENG. They manufacture the electrical steel laminations and the cores that actually make rotation possible.
And before you tune out thinking, wow, stamped steel sheets, how exciting, let me set the stage here because this is crucial. This isn't just a metal bashing company.
Right, it's not some guy in a shed with a big hammer.
Not at all. Pitti Engineering is essentially a proxy for global electrification.
Okay, that is a bold claim.
Yeah.
A proxy for global electrification. You're putting them on the same level as, what, a Tesla? A massive utility company like NextEra Energy?
I am. And I think the evidence backs it up. Look at the data. From the massive wind turbines spinning in the North Sea to the high-speed rail projects like the Vande Bharat right here in India to the EVs rolling off assembly lines in China and Europe.
So if it spins and uses electricity?
There is a very, very high probability that a company like Pitti is involved in the supply chain. They are the ones facilitating the magnetic magic that turns electricity into motion.
So if I buy into the thesis that the world is electrifying, that we're moving away from burning stuff and towards spinning stuff,
Which is an undeniable multi-decade trend.
then I have to care about this company.
Exactly. Look, you can bet on who makes the best electric car. Is it Tesla or BYD or maybe Tata Motors? You can bet on who makes the best wind turbine. Is it Siemens or Vestas? But whoever wins those wars,
They all need the core.
they all need the stack. Pitti is supplying the picks and shovels in the electrification gold rush.
Okay, I love a good picks and shovel story. It's a great analogy. But we have to verify if the shovel is actually high quality or if it's just a commodity. Because steel is steel.
That is the multi-billion-dollar question we are going to unpack. Is it a commodity or is it a highly engineered, defensible product?
So our mission for this deep dive is pretty clear. We have a stack of reports here. Financials up to February 2026, industry analysis, investor presentations. First, we need to figure out how a company based in Hyderabad and Aurangabad became India's largest exporter of these really niche components.
And I think more importantly, how they are pivoting. Because they used to just make simple parts. Now they're making complex, high-value assemblies. And that transition is the difference between a company that just survives and a company that truly compounds wealth for shareholders.
Plus, we have to tackle the big question. Is this electrification supercycle we keep hearing about actually a durable long-term trend? Or is it just another cyclical trap waiting to snapshot on investors?
It's happened before. Industrial cycles can be absolutely brutal.
They can. Okay, so let's unpack this. Let's start with the absolute basics. Section 1. What do they actually make?
Right.
I used the word guts, and you said they make the physics work, but let's get specific. I need an like, I'm 5 on electrical steel laminations.
Let's do it.
Because here is my naive assumption. If I want to make an electric motor, I need a magnet, and I need a chunk of metal for that magnet to interact with. So why can't I just take a solid block of steel, drill a hole in the middle for a shaft, wrap some copper wire around it, and call it a day? Why do I need Pitti Engineering?
You could do that, and in fact, the very first people experimenting with electricity and magnetism probably tried something very similar.
Oh, okay.
But it would be a terrible motor, and I mean terrible.
Define terrible. Like, it just wouldn't be very powerful.
It would be inefficient, for one, but the bigger problem is that it would get incredibly hot. So hot that it would probably melt the insulation off the copper wires and then catch fire within minutes.
Okay, so not ideal for my new electric car. Why? Why does the solid block get so hot?
It comes down to a really pesky law of physics involving something called eddy currents.
Eddy currents.
Like
Okay,
that.
the name sounds like something in a river.
That is the perfect analogy. So imagine a river flowing smoothly downstream. Now imagine you drop a big round boulder right in the middle of it. What happens to the water right behind the boulder?
It swirls around. You get those little whirlpools, Eddie.
Exactly. You get these little swirling whirlpools of water that spin in circles, and they don't actually go anywhere. They're just wasted energy, right? Wasted movement.
Got it.
Well, in a motor, you're using a changing magnetic field to push electrons through copper wires. When you have that changing magnetic field inside a solid chunk of conductive metal, like your solid steel block, it creates little loops of electricity inside the metal itself. Those are the eddy currents. They are electrical whirlpools.
And since those little whirlpools aren't going down a wire to doing useful work, where does all that electrical energy go?
It has to go somewhere. It turns into heat, pure waste heat. If you use a solid block of steel, those whirlpools are massive. They can flow freely through the whole block. So you're basically turning your expensive electrical energy into a very inefficient, very dangerous space heater, not a spinner.
Which is the exact opposite of what I want my EV motor to do. I want motion, not a toaster oven under the hood.
Precisely. So engineers about a century ago figured out a really clever solution. The goal is to stop those whirlpools from getting big. You want to break them up into millions of tiny, harmless ones.
Now, how do you do that?
You slice the steel. Instead of a solid block, you take that block and you slice it into incredibly thin sheets. We're talking paper thin, sometimes 0.3 millimeters, maybe 0.5 millimeters thick.
Okay, so now you have a stack of thin steel discs.
Right. But then you do one more thing. You coat each individual sheet with an incredibly thin layer of varnish or some other insulating material, and then you stack them all back up to make the shape of the block you originally wanted.
So it's like a deck of cards.
It's the perfect analogy. It's like a deck of cards that's been glued together. Because each sheet is electrically insulated from its neighbors, those eddy currents, the whirlpools, can't flow through the whole block anymore.
They get trapped inside each tiny, thin layer.
They get trapped. They can't get big. They can't gain momentum. And millions of tiny whirlpools generate vastly less heat than one giant one.
So small whirlpools mean less waste heat, which means a more efficient motor.
Drastically less heat, drastically more efficient. And that, in a nutshell, is what Pitti Engineering does. They don't just cut metal. They take this very specific type of steel, electrical steel, which has special magnetic properties, and they stamp it into these incredibly precise shapes. They insulate them and they stack them.
Okay, when you say precise, how precise are we really talking here? I mean, can't I just do this with a pair of shears in my garage?
Absolutely not. I mean, think about a motor in a high-speed train spinning at 3,000 RPM, or an EV motor spinning at maybe 15,000 RPM, if those thousands of stacked sheets are even slightly off balance.
It would shake itself apart.
It would vibrate violently. It would hum. It would scream. It would destroy the bearings in a matter of hours. The tolerance levels we're talking about here are in microns. And remember, they aren't just stamping simple circles.
Right.
These shapes have intricate teeth and slots where the copper winding has to go. If the little teeth on sheet number 1 don't line up perfectly with the teeth on sheet number 1,000, You can't wind the motor properly. It's a game of extreme precision repeated millions of times.
So Pittie's is essentially a high-precision stamping and assembly house for these motor cores,
Correct. And if you look at their product list, it tells the story of their evolution. They sell loose laminations.
which I assume are just the cut sheets put in a box,
Mhm.
the deck of cards, but not glued together yet.
You got it. The customer buys the box of loose sheets, and they have to do the stacking and bonding themselves. But, and this is the big pivot for the company, they also sell assembled stator and rotor cores.
That's the pre-glued deck,
Hmm.
the finished product.
Yes. They take those thousands of sheets, they stack them under immense pressure, they might bond them with resin or weld them along the outside, and they deliver a finished, solid, ready-to-use core.
And that's better for the customer.
It's a world of difference. Imagine you are an engineer at Siemens building a wind turbine generator. Do you want to pay a team of people to stand there and painstakingly stack 5,000 individual sheets of steel by hand and hope they don't mess it up?
No, that sounds like a quality control nightmare.
Or do you just want to buy the finished block from Pitti, test it, and drop it straight into your assembly line?
I'd take the finished block every single time.
And this brings us to what the analysts and the company itself call the Pitti way. It sounds a bit like a martial art, but it's actually a brutally effective business strategy: vertical integration.
This is a buzzword that every manufacturing company loves to use. Oh, we're vertically integrated. What does it actually mean for Pitti in practice?
It means they own the entire headache for the customer. In the old days, or for many of their smaller competitors, the business model is just stamping. You buy rolls of steel, you have a cookie cutter, which is called a die, you punch out the shapes, and you ship a crate of metal sheets to the OEM.
And then the OEM, the customer, has to deal with the scrap metal, the logistics of the sheets, the difficult assembly process.
Right. The customer has to stack them, weld them, maybe do a die casting process to put aluminum bars in the rotor. It's a huge supply chain challenge. Pitti's strategy was to say, no, we will do it all for you.
All of it.
All of it. They design and make their own dies and tooling in-house, which is an art form in itself. They do the high-speed stamping. They do the annealing to treat the steel. They do the die casting. They do the final precision machining.
Why does that make them so sticky? That's the term the reports keep using.
Okay, let's play this out. Imagine you are the procurement manager at a giant OEM that makes train engines. You have a choice. Option A, you manage 5 different vendors. One for steel, one for stamping, one for casting, one for machining, one for assembly. And if the final part doesn't fit into the engine casing, what happens?
They all point fingers at each other. It's not my fault the stamping guy was off by a millimeter. No, the machining guy messed it up.
It's a blame game, a nightmare. Now, option B. You place one single purchase order with Pitti. You send them one engineering drawing. A few weeks later, a truck shows up with a finished, tested stator core. If it's wrong, you know exactly who to call.
And there's only one throat to choke.
Exactly. But usually it's right. So once an OEM designs Pitti's finished assembly into their new train platform,
It is very, very hard to switch out.
it's incredibly difficult. Are you really going to risk your multi-million-dollar train contract and your reputation to save maybe 2% with some new, unproven vendor who might not have the casting capabilities?
No chance. You stay with the reliable supplier, you stay with Pitti.
And the financial numbers are screaming that this strategy is working. I'm looking right here at the Q3 FY26 results. It says there was a 44.9% surge in high-value assemblies.
Almost 45% growth.
Right.
In 1 year. That is a staggering number.
It's huge, and it tells you everything you need to know about their strategy. They are successfully climbing the value chain. They are not just a commodity steel stamper anymore. They're an engineering partner.
And that's crucial for their profit margins, I would imagine.
It's the whole ball game. Anybody can buy a stamping press from China. Not everybody can engineer, produce, and validate a complex, ready-to-use traction motor core for a high-speed train that has to last for 30 years.
Okay, so I think I get the product now. It's high precision, it's critical, and it's a pain to make yourself, so you outsource the whole headache to Pitti. But let's flip to the other side of the equation. Let's talk about demand. Why is this business growing so much now?
Right. This brings us neatly to Section 2, the macro tailwinds. This is the big picture, the electrification thesis.
We hear this phrase everywhere, electrify everything. But what does that actually mean in terms of a company's order book?
For Pitti, it means we are in a very rare phase where 3 massive, capital-intensive industries are all screaming for the exact same component at the exact same time.
Okay, let's break them down. Trevor, number 1 you have listed is green energy.
Specifically, wind energy. I really don't think most people appreciate the sheer physical scale of a modern wind turbine.
They're big. I've driven past them.
They're colossal. The generator that sits at the very top of that tower in that big white box, the nacelle, can be the size of a small house or a bus. And inside that nacelle are massive stator and rotor cores.
We're not talking about something you can hold in your hand.
No, we are talking about multi-ton, precision-engineered components. And these things are packed with laminations, mountains of them. But here's the kicker for a wind turbine. Efficiency is everything.
Why is it more important there than, say, in my blender?
Because of scale and time. If you lose just 1% of the potential energy in a wind turbine generator due to bad laminations causing heat loss over the 20 or 25-year life of that turbine, that adds up to a fortune in lost electricity sales for the operator.
So the utility companies, the Siemens and Vestas of the world, they will pay a premium for the highest quality steel and the most precise stacking.
They have to. It's a non-negotiable. And the world is adding something like 50 gigawatts of new wind capacity every single year. That represents an enormous, continuous demand for high-grade electrical steel laminations. Pitti is a key player here.
Okay, driver number 2, transport. And here in India, that means one thing above all else: rail.
Rail is just a monster of a demand driver. The Indian Railways modernization push is a multi-decade story. We aren't just talking about laying a few new tracks. We are talking about a complete overhaul. The Vande Bharat Express trains, the metro systems popping up in every major city, the dedicated freight corridors, the high-speed rail projects.
I was reading about the Vande Bharat trains. They're fascinating. These are electric train sets, so they don't have one big locomotive at the front pulling everything.
That's right. It's a concept called distributed traction.
So they have electric motors distributed underneath the carriages all along the train.
Which means you have more motors per train. And every single one of those electric bogies uses massive, heavy-duty traction motors. Now think about the environment those motors have to operate in.
Brutal. Extreme heat in the summer, dust, monsoon rains, and constant vibration.
Intense, relentless vibration for millions of kilometers. If you have a poorly bonded lamination stack in a train motor, that vibration will literally tear it apart. The stack will delaminate, the efficiency will drop, and the motor will fail. You cannot use low-quality components. It's a safety issue.
Pitti has positioned itself as a key supplier for this whole rail revolution.
They have. And then, of course, the other huge side of transport is EVs. Electric vehicle.
And the big one, the shift from the internal combustion engine to the electric motor.
It's happening, maybe not in a perfectly straight line, there are bumps in the road, but the long-term trend is undeniable. A combustion engine needs pistons, cylinders, valves, crankshafts, camshafts, hundreds of moving parts.
An EV needs a battery and a motor, and that motor needs a core.
So Pitti is essentially trading the old world of mechanical complexity for the new world of electromagnetic complexity.
That's a beautiful way to put it. And there's a third driver you mentioned.
There is. Driver number 3, industrial automation.
Okay, this one sounds a bit more boring than high-speed trains and EVs.
It's definitely unsexy, but it pays the bills and it's incredibly steady. All around the world, factories are modernizing. They're using more robots, more precise conveyor systems, more efficient pumps and fans and compressors. All that requires better, more efficient electric motors.
So when you add up wind, rail, EVs, and industrial automation, what is the total addressable market? What's the TAM?
It's huge. The various sources we have estimate the global TAM for laminations and motor cores is somewhere in the range of $15 billion to maybe $25 billion annually.
$25 billion. That is a very, very large pie.
It is. And remember, Pitti is the largest player in India, but on a global scale, they still have a relatively small market share. So there's a huge runway for them to grow, especially in exports. They are a big fish in the growing Indian pond, but they're still a small but growing fish in the global ocean.
It really is the perfect pick and shovel dynamic we talked about.
It is. Can you explain that again for the listeners who might not be familiar with the term?
Sure. During the gold rush in California in the 1800s, the people who consistently made the most money weren't necessarily the prospectors digging for gold. That was a high-risk gamble.
Most of them found nothing.
Exactly.
Yeah.
The ones who got rich were the guys selling the picks, the shovels, the wheelbarrows, and the denim jeans to all the miners. They didn't care who found gold. They made money on every single person who tried.
And that's Pitti. They don't have to bet on whether Tesla wins or BYD wins or Tata Motors wins the EV race. They don't have to bet on whether wind beats solar in a specific region. As long as the world is using electricity to create motion, someone needs to buy the shovel. And in this case, the shovel is the lamination stack.
But wait a minute. If the market is a $25 billion pie, surely everyone wants a piece of it. There must be intense competition. Which brings us to Section 3. How do they win? What's their competitive advantage? What makes PD special?
There are a few layers to this, but the first and most obvious one is scale. In a heavy manufacturing business like this, size is its own quality. Pitti is the largest manufacturer and exporter of electrical laminations in India, period.
Why does scale matter so much? Why can't a small, nimble shop compete with them?
A few reasons. First, purchasing power. PD buys electrical steel in massive, massive quantities. They get better pricing from the steel mills than a small guy who's just buying 10 rolls.
So their raw material cost is lower from the start.
It is. Second, operating efficiency. They can run their massive factories 24/7, which means they are spreading their fixed costs, their rent, their electricity, their administrative staff over millions and millions of parts. A smaller shop just can't match that cost structure.
And they export a lot, right? That gives them geographic diversification.
They do. They export to 11 countries across 6 continents. They have a global footprint, which de-risks them from a slowdown in any single market. But the real moat, the deep, wide ditch that keeps competitors out, is the certification barrier.
Talk to me about that. What does that mean?
It's not just about buying a stamping machine and setting up shop. It's about trust and validation. If you want to supply a critical component for a medical MRI machine or a part for an aerospace application or an engine for a high-speed train, the OEM, the original equipment manufacturer, needs to validate you as a supplier.
That sounds like a lot of paperwork.
It is years and years of paperwork. It's rigorous testing. It's multiple site visits by their engineers. It's quality audits. You can't just walk up to General Electric or Siemens and say, hey, I made this motor core in my garage, want to buy it. It can take 2 to 3 years, sometimes longer, just to get approved for a single critical component.
Wow.
Yeah.
So once you are in, you are really in.
Exactly. The switching costs for the customer are enormous.
Right.
Pitti has those relationships. They have those certifications. They have been nurturing them for decades. That is a very deep and very effective moat. It takes a huge amount of time and capital for a new competitor to build that kind of trust.
Okay, that makes sense. Now, we have to talk about a major strategic move they made recently that the reports are all focused on. The acquisition of a company called Bagadia Chaitra Industries, or BCIPL. This happened back in March 2024.
This was a pivotal moment for the company, a real game changer. Before this acquisition, Pitti was very geographically concentrated in Telangana and Maharashtra, basically Hyderabad and Aurangabad. That's central and western India.
And BCIPL gave them a major foothold in the south, in a place called Tumkur in Karnataka.
Correct. And that specific geography is incredibly strategic.
Why? I mean, it's all India. Can't they just ship the parts on a truck?
They can, but think about what they're selling. They are selling heavy stacks of steel. It is one of the densest, heaviest products you can ship.
So logistics costs are a huge factor.
They eat your margins alive. Shipping a 5-ton stator core from Hyderabad all the way down to a customer in Chennai or Bangalore costs a lot of money in fuel and transport.
So being physically close to your customer base matters immensely.
It matters a great deal. And South India is a massive hub for certain types of manufacturing pumps, motors, appliances, and increasingly EV components and assembly plants. Being in Tumkur brings Pitti physically closer to that entire ecosystem of customers.
So it reduces their logistics costs and makes them more competitive on pricing.
Significantly, it protects their margins. Plus, it didn't just give them a location, it added 16,000 tons per annum of new capacity.
That's a huge jump in their potential output.
It is. It was a very clear signal to the market that Pitti wasn't just content with slow organic growth. They were willing to go out and buy growth to capture market share quickly and aggressively.
We mentioned it earlier, but I want to double-click on this shift to assemblies because the sources highlight it over and over again as a massive differentiator.
It is the single most important strategic evolution in their business model over the last decade. It's the move from selling commodities to selling solutions.
We talked about it briefly, but financially, what is the impact?
It's profound. Look, when you sell loose laminations, you're competing largely on the price of steel plus a small markup for the service of cutting it. It's a brutal low-margin game.
Because everyone in the world knows the market price of steel on any given day, so they can squeeze you on your margin.
They can, and they will. But when you sell a fully assembled, machined, and validated rotor core, you are no longer just selling steel. deal. You are selling engineering expertise. You are selling quality control. You are selling a value-added product. And for that, you can command a much higher price and a much healthier margin.
And as we discussed, the customer becomes stickier.
Exactly. And the data from Q3 FY26 reinforces this perfectly. As you said, volume in their high-value assemblies grew almost 45%, while the volume of low-margin loose parts grew much, much slower.
That tells you it has to be a deliberate strategy.
It absolutely is. They are likely, and this is smart, turning away some of the low-margin loose lamination business to free up capacity for the high-margin assembly business. That is a sign of a mature and disciplined management team making the right hard choices for long-term value creation.
Speaking of value, let's turn to the scorecard. It's time for Section 4, the financials. How is the business actually performing on paper?
The top-line growth trajectory has been really impressive. If we look back at fiscal year 2022, their revenue was around 970 crores. By FY25, just 3 years later, it hit 1,743 crores.
So that's a CAGR, a compound annual growth rate of about 16%.
That's very solid, consistent double-digit growth.
And where are they now as of the latest numbers?
As of February 2026, they are on track to hit around 1,950 crores for the full fiscal year. And the most recent quarter, Q3 FY26, saw revenue up 15% year over year to 484 crores.
So the growth story is intact. The top line is humming along. What about the bottom line? What about profitability?
This is where the story gets a bit more nuanced. Their EBITDA margins, that's earnings before interest, tax, depreciation, and amortization, are actually quite healthy. They're hovering in a solid range of 16% to 17.5%. For a heavy manufacturing business, that is very respectable.
And there's always but with financials. When I look at the net profit margins, they're much lower. They're down in the single digits, 5% to 8%. Why is there such a big squeeze? If they're making a healthy 17% at the operating level, where's the other 10% of the revenue going?
This is where we have to get into the weeds of the cost structure, and it's a critical point for any investor to understand. Two main things are eating that profit before it gets to the bottom line. The first and most obvious one is raw materials.
Steel is expensive.
It is, and it accounts for a huge chunk of their costs. And as we know, steel prices can be volatile. But the second factor, and perhaps the more important one for understanding the long-term story, is the combination of depreciation and interest.
And that's because they are building so much new capacity.
Exactly. We just talked about the BCIPL acquisition. We've talked about them expanding their other factories. That all costs a huge amount of money. To fund it, they have taken on debt, which means they have to pay interest to the banks. That's a real cash expense.
Okay, so interest expense eats into profit. What about the depreciation?
When you buy 100 crores worth of shiny new German stamping presses and machinery, accounting rules say you can't just expense that all in 1 year. You have to depreciate it over its useful life.
So you expense a portion of its value every single year.
Right. And here's the key. Depreciation is a non-cash expense. They already spent the money to buy the machine 2 years ago. But on the profit and loss statement today, they have to deduct a chunk for depreciation.
So depreciation lowers the reported net profit, making the company look less profitable than it might be from a cash flow perspective.
Precisely. It depresses that final net profit number. But if you look at their cash flow statement, the picture is often much healthier. What you're seeing is a classic characteristic of a growth stage industrial company. They are in a heavy investment cycle.
They are sacrificing today's reported net profit for tomorrow's growth and capacity.
That's the bet they're making. They are betting that the demand from wind, from rail, from EVs will absolutely be there in the coming years. So they are building the factories and buying the machinery now to meet that future demand. And this creates a powerful effect that investors love called operating leverage.
Okay, break that down for me. I love that term, but let's make it concrete.
Yeah.
What is operating leverage?
The best analogy is a hotel. It costs a massive fixed amount of money to build a 100-room hotel and to keep the lights on and pay the staff every day. If you only have 10 guests staying, you are losing a ton of money. If you have 50 guests, you might be breaking even.
Right, you're covering your fixed costs.
But once you've covered all those fixed costs, the revenue from the 51st guest is almost pure profit. The 52nd guest is pure profit. The 100th guest is pure profit. The profit margin on those incremental customers is huge. That is operating leverage.
So Pitti's building the hotel right now.
They are building a massive hotel for electric motor components. Right now, they are still filling the rooms, ramping up. But as they fill that new factory in Tunker to 80%, 90%, 100% capacity...
Yeah, revenue will grow, but their fixed costs. The depreciation on the building, the interest on the loan will stay the same.
Exactly. So the profit on those last few widgets or the last few thousand tons of laminations is massive. Once they cross a certain capacity utilization threshold, their net profit margin should theoretically expand significantly. That is the pot of gold at the end of this investment rainbow.
And it's a big but. They have to fill the factory first.
They do, and that brings us directly to the risks.
Okay, good. We've spent a lot of time praising the business model. We've talked about the growth, the sticky customers, the invisible engine thesis. But I want to pull the emergency brake for a second here.
It's always a healthy exercise.
Because if this was a guaranteed, can't-lose lottery ticket, the stock would be trading at 1,000 times earnings. It's not. So let's get serious and talk about Section 5. What could go wrong? Because investing is always about protecting the downside first.
Absolutely. And with a company like Pitti, there are very real, tangible risks. This isn't a software company where you write the code once and sell it 1,000,000 times with zero marginal cost. This is heavy industry. It's tough.
And the first, biggest, scariest risk on my list is cyclicality.
The beast that eats industrial companies for breakfast.
Explain cyclicality in this specific context, because a lot of people hear electrification and they think it's a secular trend, which means it's a straight line that goes up and to the right for 20 years because we have to save the planet.
That's the narrative, and the long-term narrative is probably correct. But the reality is that Pitti's customers are businesses. They are giant, capital-intensive businesses, factories, railway ministries, wind farm developers. Their spending is tied directly to the health of the global economy.
So if Europe or the U.S. goes into a deep recession,
Let's play that out. If Europe goes into a recession, do they suddenly stop wanting green energy? Of course not. But do they delay the final investment decision on a new 500-turbine offshore wind farm because interest rates are high and financing is tight?
yes,
Yep.
absolutely. They pause the project for a year or two.
They pause. And when the big developer pauses, Siemens pauses its orders for generators. And when Siemens pauses, Pitti's phone stops ringing for those export orders.
And meanwhile, Pitti has just finished building this massive new factory in Tumkur and has debt to service.
That's exactly it. That's the dark side of operating leverage. We praised it on the way up because it boosts profits, but on the way down, it crushes you.
Because the revenue disappears, but the costs don't.
You still have to pay the interest on the debt you took to build the factory. You still have to pay the depreciation expense. You still have to pay your core staff. But the revenue isn't there to cover it. The losses can mount very, very quickly.
We actually saw a little hint of this in the Q3 FY26 numbers, didn't we? Remember the report mentioned export challenges.
We did. Exports were a bit soft. And why? Because Europe and the U.S. were dealing with macro headwinds. Inflation, high interest rates, potential slowdowns. Fortunately for Pitti, the domestic Indian market is absolutely booming right now.
So the Indian government, buying trains like there's no tomorrow, saved the quarter.
It did. The domestic story offset the international weakness. But what happens if India and the world slow down at the same time? That is the nightmare scenario for an industrial company like this. Their revenue could drop 30% or 40% very quickly.
Okay, let's talk about risk number 2. This one is fascinating. The axial flux problem.
Ah, yes. The sci-fi risk.
Sounds like something from Star Trek. Captain, the axial flux compensator is destabilizing. But seriously, what is this, and is it a real threat?
It is a genuine potential long-term engineering disruption. So 99% of the electric motors we've been talking about, the ones in trains, factories, and most EVs today, the ones Pitti makes parts for, are what we call radial flux motors.
Radial, meaning the magnetic force goes outwards from the center.
Exactly, from the center out like the spokes on a wheel. These motors are robust, they're reliable, and we've known how to build them for over 100 years. But they have one major drawback. They are heavy, they require a lot of iron and steel to properly direct that magnetic flux.
And Pitti sells that iron and steel by the ton.
Pitti sells weight. That's a core part of their business model. Now enter axial flux. In these newer motor designs, the magnetic field goes along the shaft, parallel to it. The rotors are shaped like flat discs, like a pancake sandwich.
And what's the benefit of that design?
They are incredibly compact and power-dense for their weight. They are much, much lighter. And crucially, they often use different materials or construction methods.
Do they still use laminations?
Sometimes, but often in very different forms. Or they might use something called soft magnetic composites, which is basically powdered metal that's pressed into a shape. The bottom line is they generally use less steel.
So if the world suddenly switches to axial flux motors tomorrow, Pitti's left making buggy whips in the age of the automobile.
That is the extreme bear case. If every EV, every train, and every factory switched to axial flex motors, Pitti's core market would shrink dramatically.
How likely is that scenario?
Happening tomorrow, zero chance.
Why not? If they're better, why not switch?
Two reasons: cost and maturity. Right now, axial flex motors are very expensive to manufacture at scale. They are great for a high-performance supercar like a Ferrari, or for an electric aircraft where every single gram of weight is the enemy. But for a freight train locomotive,
A freight train doesn't care if its motor weighs an extra 500 kilos.
exactly. In fact, for traction, that extra weight can actually be a good thing. For a massive wind turbine, you want proven reliability over 20 years.
Yeah.
You don't want to be experimenting with brand new technology at the top of a 100-meter tower in the middle of the ocean.
So the heavy industry part of Pitti's business, the rail, the power generation, the big industrial motors, that's probably safe for a very long time.
I would say so, but the EV part of the market,
That's where the risk is.
that is where the risk is highest. If a major player like Tesla or BYD figures out how to mass produce cheap, reliable axial flex motors, that specific segment could shrink for Pitti. It's a long-term technology threat that you have to keep an eye on.
Okay, so it's a disruption to watch, but maybe not a death sentence yet.
Correct.
Finally, let's talk about the most basic risk of all, the raw material, steel.
The commodity trap. At the end of the day, Pitti is a converter. They buy steel, they add value to it by cutting and assembling it, and then they sell it.
Now, you would assume that if steel prices go up, they just pass that cost on to the customer.
Right. Theoretically, yes. Most of their contracts have pass-through clauses. If the price of electrical steel goes up by $10 a ton, they are allowed to charge the customer $10 more.
So what's the risk then? It sounds like they're protected.
The risk is the lag. It is all about timing and working capital. Let's say there's a supply shock or a war, and the price of steel spikes by 40% this month. Pitti has to buy that expensive steel now with cash to keep the factory running.
They need the inventory on hand to fulfill their orders.
Right. But their contract with, say, General Electric might state that we adjust prices based on the average of the previous quarter. So Pitti is forced to pay the very high price for steel today, but they can't actually invoice their customer at that higher price for another 2 or 3 months.
So for 3 months, they are massively out of pocket. They're funding the price difference.
Exactly. Their working capital requirements balloon. All their cash gets tied up in expensive inventory. They might even have to borrow more money from the bank just to buy raw materials. If they don't have a very strong balance sheet, a massive, sudden spike in steel prices can cause a serious liquidity crisis.
It's like buying dinner for a huge group of friends who have all promised to pay you back in 3 months. You better have a very big credit limit.
That's a perfect analogy. And in this business, the dinner bill runs into the hundreds of millions of dollars.
Okay, that makes the risks very clear. Let's look at the present and then the future. Section 6. Recent performance and the outlook from here. We have the Q3 FY26 numbers for the quarter ending in December 2025.
I think the big headline here is resilience. We keep coming back to it. Despite those export challenges that the company explicitly mentioned, they still managed to grow their overall revenue by 15%.
That feels very significant,
Mm.
because if exports were weak, that means the domestic Indian market must be absolutely on fire to make up for it.
It is. The Indian capital goods cycle is in full swing. The government is spending heavily on infrastructure, the railways are buying, and private capex is finally coming back. Pitti is leaning heavily on its home turf to weather the global storm, and it's working.
And what's more, their margins actually improved. The EBITDA margin hit 17.5% in that quarter.
That speaks to strong operational efficiency. Even with some headwinds, they managed to squeeze more profit out of every rupee of sales. That's a very good sign for management quality and execution.
Looking forward, what are the new growth vectors? Where do they go from here now that they have all this new capacity?
They are actively diversifying. One really interesting new area they're looking to enter is forgings.
Forgings. Now, that's very different from stamping, isn't it?
Yeah, totally different process. Stamping is cutting sheet metal. Forging is taking a solid chunk of hot metal and hammering or pressing it into a shape, like a blacksmith. They are planning to get into this market. It's a form of backward integration for them.
How so? What would they make?
Things like the shafts that the rotor cores are mounted on. It sounds like they're trying to capture more value from each existing customer.
A bit of cross-selling. Hey, Mr. Siemens, you already buy our stator cores. Why not buy the machine shaft from us, too?
Exactly. And then there are new sectors. I see aerospace mentioned in their latest presentation.
That sounds ambitious.
It is. They're talking about making components for things like landing gear. That is extremely high precision, high value work. If they can crack that market and get the certifications, the margins are beautiful.
And the other new one I saw was data centers. That seems random.
It's not when you think about it. We think of data centers as just chips and servers, but what happens to a Google or Amazon data center when the power grid goes out?
It's a catastrophe. Everything crashes.
Right. So every single data center has massive backup power systems, usually huge diesel or natural gas generators. Those generators need huge alternators to produce electricity.
And Pitti makes the cores for those alternators.
Correct. As AI drives this massive boom in data center construction, the demand for reliable backup power skyrockets. Pitti plays a crucial role there, too. It's another quiet, unsexy, but very large market.
And, of course, we can't forget rail.
The gift that keeps on giving for any Indian capital goods company. The Indian Railways modernization and expansion order book is massive and provides a baseline of steady demand that helps to stabilize the whole ship, even when exports are choppy.
Let's touch on management quality for a moment. We did note that the promoter holding, the amount of the company owned by the founding family, has dropped slightly over the last 3 years. That usually raises an eyebrow for investors.
It's worth noting, yes, it looks like a drop of about 5%, but you always have to look at the context. Sometimes promoters sell a small stake to pay off personal debt, or for estate planning, or just to diversify their own wealth. It doesn't always mean they've lost faith in the business.
So are they treating the company like a personal piggy bank?
From everything we're seeing, it doesn't look like it at all. In fact, it's the opposite. They are being extremely aggressive in reinvesting every spare rupee back into the business.
Which explains why there are no real dividends to speak of.
Very, very small. Basically negligible. All the cash the business generates is going right back into CapEx. For a shareholder, you have to make a clear choice. Do I want a small dividend check in my hand today? Or do I want the company to use that money to try and double in size over the next 5 years? Pitti's management is clearly pitching the latter.
It's a growth stock, plain and simple, not an income stock.
It is. And the management team seems laser-focused on execution. The successful immigration of BCIPL, the steady expansion of capacity, the strategic move up the value chain to assemblies. These are all the right moves.
So we've looked at the invisible engine, we've looked at the numbers, we've gone through the risks. Let's bring it all home. The outro.
If we synthesize everything we've discussed, Pitti Engineering is the absolute classic picks and shovels play on the electrification of the world. They have successfully transitioned from being a simple, replaceable parts maker into a deeply integrated, essential engineering partner.
They've made themselves critical to the supply chains of the giant companies that are building the future, whether that future is a wind farm in the ocean or a high-speed train across India.
But here is the final provocative thought I want to leave everyone with.
Go for it.
As engines become silent and invisible, as we move from the noise and complexity of combustion to the silence of electric, the underlying complexity of manufacturing them actually increases. It's not easier, it's harder.
The precision required is higher.
Much higher. And Pitti has bet the farm on this trend. They have expanded their capacity massively. You've got 16,000 tons of new capacity coming online from the BCIPL acquisition alone.
They built it.
They built it. Now, the billion-dollar question is, can they fill it? The next 12 to 18 months, fiscal year 2027, will be the ultimate litmus test for their strategy and their timing. If the global economy holds up and this electrification trend continues its relentless march,
That new capacity turns into a cash printing machine.
yeah,
The operating leverage kicks in.
exactly, the profits could explode higher. But if we hit a global manufacturing recession, if the world just stops building things for a year, then they are left with massive empty factories, high debt payments, and a lot of depreciation eating away at their profits. Their timing was either absolute genius or it was reckless.
And we're about to find out which.
We are.
That is the cliffhanger. So
Yeah.
the next time you see a fan spinning or you hear the hum of a train pulling into the station or you plug in your EV at night,
Stop for a second and think about the thousands of razor-thin, perfectly stacked sheets of steel inside that motor spinning at 3,000 RPM.
the invisible engine that makes it all work.
Thanks for listening to The Deep Dive. We'll see you next time.